So we added the load balancer to our system, and with that, we included an extra server or two to improve our availability. And what are we missing now? So the thing we are missing is the user experience. All the calls, all the reads and the writes we're making are going to the database data tier, which is kind of slow. So at this point, what we need is we need to have a cache to cache the frequently used data or some other data according to certain parameters so that we can improve our latency. So that's how, so let's talk about how a cache works, right? So usually cache store the data in the memory. So it's not a persistent storage. It's a storage in memory. So I guess one downside of the cache would be that if in case of like a power outage, you will lose everything. So you can't just rely on cache. You need to have some persistent storage at some level, but you can use caches to improve the latency and the response times. So let's see how a cache works. Our web server gets a request from the user, and without the cache, if it didn't have the cache at all, it would make a call to the database directly to get the required data. Imagine we received a GET request, get users or something like that. With a cache layer, the web server will first check the cache layer and check if it has the required data. If it does, it just if cache has the required data, it returns the data back to the server. If it doesn't, our web server checks the database, it gets the data, updates the cache so that the consequent reads can be served directly from the cache. So we have a number of considerations when we're using a cache. So first, we have to decide when to use a cache. We want to use cache when the data is read frequently but modified infrequently. That's the whole point. You want to set up an expiration policy to the cache because you don't want to have stale data in the cache living there forever. We want to keep the data store, our persistent data store, and cache in sync. What I mean by that is that if we have the data A in cache and we have the data A in database, and then there's a read request coming for data A into the database, and let's say A becomes A1, the data A becomes A1, and so we want to reflect that change in the cache, because if we don't, we still have the data A in the cache, but we have stale data. So, and we don't want to respond with outdated data to our users. Obviously, we want to prevent a single point of failure when we talk about the caching layer. For that, ideally, we want to set up not only one cache server, but multiple cache servers. And the last but not least, one important aspect of working with caches is the eviction policy. Eviction policy is the concept that when the cache is full, let's say our caches can only hold 10 megabytes of data, and when we have 10 megabytes of data and we want to insert the 10 and first megabyte of data, we want to evict some other data, otherwise we won't be able to store it. So that's eviction. So there are different approaches to eviction, different eviction algorithms or policies. One of them is least recently used cache. In the least recently used eviction policy, the least, as the name suggests, the least recently used element will be evicted from the cache at that time. Least frequently used is a similar but a different policy. In that algorithm, the least frequently used element will be evicted at time of cache capacity, when we reach the cache capacity. But we also have first in, first out eviction policy as well. These are all the different eviction policies. Speaking of cache, we should also talk about content delivery networks. Content delivery networks are similar to cache, but they're mostly for static content. There is some content delivery networks or CDNs for dynamic content, but that's out of the scope of this video for now. So a simple workflow for a CDN is that the first user, let's say this one in the top left corner of the diagram, that user wants to retrieve an image, and first it checks the CDN. If the CDN has that data, it'll return back to the user right away. But if it doesn't, it goes to the origin. The origin could be a web server or object storage. The object storage or the web server, which is the origin, returns the image to the CDN, and we save the image in this, store the image in the CDN at that point, and then it returns the image back to the user. And when the second user here requests the same image, we can directly return it from the CDN. With CDNs, cost is an important issue because usually we don't set up our own CDN service. We use third parties for that, and you pay for CDN for like whenever the data comes in and whenever the data goes out. So you don't want to cache infrequently used assets because you will be paying for it. So you need to be a little smart about it. Cache expiry is similar to like the cache that we're the expiration date we were talking about, or expiration policy we were talking about for caches. We want to set up a cache expiry, especially for time sensitive content. It should neither be too long or too short, because if it's too short, like the CDN will be making requests to we will be getting the data from the origin quite often, and if it's too long, it's going to become stale. So that should be set appropriately. CDN fallback, we should consider how our website and application copes with CDN failure, right? So if there's a temporary CDN outage, clients should be able to detect problems and request sources from the origin. And invalidating files when needed. We have to remove a file from CDN before it expires by performing these operations. So we can invalidate CDN using CDN object using APIs provided by the CDN vendors, or we can use object versioning, right? To version an object, we can add parameters to our URLs, such as a version number. So after adding the cache and content layer, a CDN layer, our design will look something like this. Again, to recap, the static assets will be stored in the CDN, such as JavaScript files, CSS files, images, and they will not be served by the web servers anymore. They are fetched from the CDN to improve performance. And in a similar manner, database load will be improved by the caching layer we just added. So that's all for this video. And in the next video, it's going to be an interesting topic. We're going to talk about state in the web tier, and if we should use a stateful web tier or a stateless web tier. So see you there.